Hi, I'm Seth with Hornady Manufacturing. We're out at the range today to show you how to take your rifle system and set it up using the Hornady Ballistic app. Within the app, you'll have two options. The first is the traditional BC-based calculator, and the second is the advanced Ford-off ballistic calculator, which uses bullet drag coefficient instead of ballistic coefficient to produce the most accurate trajectory calculations available. Let's get started. Before we take our first shot, there's some notes that we need to take. The first is our environmental data. To do that, I'll be using a Kestrel weather meter. We'll need our altitude above sea level. We'll need our uncorrected pressure, the temperature, and the humidity. Next, we'll get the distance to our zero target. Need a rangefinder for this. We'll also want to get the shooting angle as well. So we're at 101 yards at a -1 shoot angle. Next, we'll get the sight height. That is the center of the scope axis to the center of the bore axis. To do this, we want to be accurate within 1/10 of an inch. You'll need a set of calipers. The way I like to do it is to use this vent hole on the Remington 700 Action to the seam of your scope rings. We're at 1.9 inches. Lastly, we'll need the wind speed and direction. Today, we have a 1 mile an hour wind from 11 o'clock. And that's all we need. Let's take our first shot. As with any trajectory calculator, the outputs are only as good as the inputs. So we've got good accuracy there. Now we're going to take our muzzle velocity and shoot our first 5-shot group at 101 yards. So we've retrieved our target. Looks like we shot a nice group, and I could stand to move 1/10 of a mil left, and we're a little bit high. So we're going to measure how high from center line each bullet impacted, and then get an average for how high we are. So my first shot, 0.313. 0.342. 516. 0.695, and the last shot, 0.691. So I'm an average of 0.511 inches high. Lastly, we need our muzzle velocity, so we'll check that out. And that 5-shot string averaged 2783 feet per second. We're now ready to input this to achieve our zero angle, and then we'll step out to 600 yards to get our axial form factor. To open the Hornady Ford-off Ballistic app, simply select the icon on your home screen. You'll be prompted to sign in or create an account. The reason we have opted to create an account is so that we can store all of your information and you can access it from any device. Once successfully logged in, you'll be greeted by this screen. Your first option is to select the Ford-off ballistic calculator. The next option is the standard ballistic calculator, which uses BC. You can access your favorites profile to edit and build favorite rifles. The Hornady on the web icon will simply take you back to our website, and the Help and Support tab will have videos and descriptions. Let's create our favorite rifle profile. If you do not have any profiles created, simply select one of the plus sign icons. We will create this profile to use the Ford-off app. We'll be greeted by this screen to create our profile. We'll give the rifle a title. In this case, it is a custom 6.5 Creedmoor. The rifle is built on a Remington 700 Action. with a Bartlett barrel. This rifle is running a vortex scope. Next, we'll select our bullet. This bullet library are projectiles that we have shot over the Doppler radar. Not only do we have Hornady's popular match bullet, but we also have bullets from Berger, Lapua, Sierra, and Warner Tool. We are constantly updating this library. Today, we are shooting the 140 grain ELD match. We will now set the load information. We are shooting factory ammunition. However, if we were shooting a hand load, we could select this icon here to create the case, the brand of primer, the overall length, the charge weight of powder, and then which powder. Next, we have the ammunition temperature sensitivity. If you are a hand loader, you'll simply select this powder and you will have a library of powders that we have tested to get their temperature sensitivity. In this case, we are shooting factory ammunition. I have personally tested this ammunition over a chronograph and have established that it has a 0.7 feet per second change per degree. To toggle on the ammunition temperature sensitivity, simply select the icon and input your temperature sensitivity factor. We will now select Save in the upper right-hand corner. We are now ready to set up the rifle information. When greeted with this screen, you will have multiple ways to change each input. The center bar is a very rough unit of measure. You can use the plus and the minus buttons for a very fine unit of measure, or you can simply select the number itself and manually override it. Our muzzle velocity today was 2783 feet per second. We are now ready to find our zero angle. To do that, simply select the Use Zero Angle red letters. And we need to find the zero angle. The zero target distance today was 101 yards. Now we shot a 5-shot group at 101 yards and we averaged 0.511 inches high. So I estimate that our true zero range is going to be closer to 125 yards. The sight height on the rifle that we measured was 1.9 inches, and that barrel is equipped with an 8-inch twist. We'll leave the axial form factor at 1. The shooting angle was -1 degree. We are at 1883 feet above sea level at 28.29 inches of mercury, 53 degrees Fahrenheit, and 43% humidity. The wind speed was 1 mile an hour from roughly 300 degrees. The bore diameter will be pre-selected when you select your bullet. We're now ready to find the zero angle. On this screen, it tells us that at our zero range target, which was 101 yards, if we had a 125 yard zero, our impacts would be 0.194 inches high, but they were not. They were actually 0.511 inches high. To change that, simply select the plus sign. You'll press the plus sign until the impacting at zeroing target reflects what you measured. 0.515 and 0.506 kind of splits the difference. We'll go with 0.506 and select Use Zero Angle. We will now select the Save icon in the upper right-hand screen. Further below, we can change our input and output options from US standard to metric. And we can also change our result outputs. Now my scope is equipped with MRADs, but we could select minute of angle or inches. We're now ready to select the Save icon. You've now successfully created your first favorite rifle profile. Now that you've successfully created your favorite rifle profile, we need to shoot for axial form factor. We recommend shooting at distances between 300 to 800 yards. Today, our target's at 599 yards. To obtain the dialing solution, simply select the favorite profile that you've just created and press the select icon on the left side. Here you'll be greeted by the Hornady FORDOF HUD, or heads-up display. We always want to enter our environmental variables. If you are equipped with a Kestrel 5500 or higher, or the weather flow meter with Bluetooth, you can pair that weather meter to electronically input the variables. We will manually input them now. The altitude is 1883. The pressure measured 28.29. The temperature is 53 degrees with 43% humidity. We'll select the Save icon in the upper right hand of the screen. Below the atmospheric data, you have three icons: shooting angle, firing azimuth, and earth-based effects. The shooting angle can be obtained multiple ways. You can simply aim your rifle at your target and set the cell phone on your barrel to get the angle, or you could use an old-fashioned slope-dope type apparatus, and in our case, we use the rangefinder. So we will select the override button and we'll manually input the angle. The next option is firing azimuth. Select the firing azimuth icon. Again, there are multiple ways to achieve this. One, you could get your firing azimuth from a rangefinder that is equipped with that equipment, or you can simply point the tip of the bullet at the direction you're shooting. And today we're shooting at basically true north. You can either hit capture or you can manually input it in override. Lastly, you can choose earth-based effects. Earth-based effects is the curved earth effect, or Coriolis. This is generally unnecessary for anything sub 1,000 yards. If you'd like to turn it on, you simply select this icon, and you'll have to either input manually your latitude or let your phone's GPS input it for you. We're now ready to calculate our dialing solution for our 599-yard shot. You can scroll this wheel up and down to get to your desired range, or you can simply press in the middle and manually input your distance. Next is wind speed. Today we have a mild 1 mile per hour wind. To adjust the wind speed, simply scroll the wheel up and down to your desired speed. Lastly, we have the wind direction. Again, you can scroll this wheel up and down to get your desired wind direction, or simply press it and you'll be greeted by this screen. You can now simply drag the arrow in the direction that the wind is blowing. We are now ready to dial this solution and put a 5-shot group on paper to obtain our axial form factor. Now that we have your profile created in the FORDOF app and you have your rifle system saved as a favorite, we're going to shoot for axial form factor. Now it's important to do this because from barrel to barrel and muzzle device to muzzle device, you'll get a very slight variation in drag, and that needs to be accounted for. We recommend shooting for your axial form factor at distances between 3 and 800 yards. Usually the furthest distance that you feel comfortable making a good wind call and putting a tight group on paper. I like to use a target like this. I'll make just red lines with a marker, and I'm really not so much worried about the left and right. I'm more worried about how far I am from the center line of my aiming point, high or low. So we'll go ahead and run this down there and put 5 shots on paper. We've ranged our target hanger at 599 yards. Let's get started. All right, so we just put our 5-shot group on paper from 599 yards. Tell you what, that's probably one of the better groups at this range that rifle shot. About a half minute here, no wind scenario today. The important thing though is not the group size, but how high each individual shot is from the center line. So we'll go ahead and get those measured. First we got 2 1/4 inches. Go 1 1/8. 3/8 of an inch. And minus 1/4 on this one. And from the center of the bullet hole to the center line, we're plus 1/8 of an inch. What we'll do is average all of these heights to get the median group center, and we'll measure that to center line here to get how far high we are. We'll input those numbers into the Fordhoff calculator to get our axial form factor. We've just put our 5-shot group on paper at 599 yards, and we've measured each individual shot's distance from my true center line, and we found that my group averaged 0.725 inches high at 599 yards. Now we'll use that information to calculate our axial form factor. The first step is to change the outputs to inches so we can see how many inches the Fordhoff called out for. To do this, simply select the back arrow in the upper left-hand part of the screen. We'll select the profile and we'll edit it by selecting the edit icon. If we scroll to the bottom, the results output in inches. We'll select the save icon. We'll now go back into the heads-up display. Our dialing solution called out for 72.61 inches of drop, and our actual drop was 0.725 inches different than that. So we'll use the axial form factor to account for the difference. Select the back arrow in the upper left-hand part of the screen, press your profile, and select the edit icon. Under the set rifle info, we will be able to adjust our axial form factor. It is preset to the average drag curve, or 1.0. Now our impacts were higher than expected. So let's try an axial form factor of 0.99, just 1% different. We'll select the save icon in the upper right-hand part of the screen, and we'll go back into the Hornady heads-up display by selecting the profile. By adjusting it 1%, it has changed, but not quite enough to account for a 0.725 difference. Let's go back and adjust it one more time. Instead of 0.99, let's go a little more aggressive and try 0.97. We'll save these profiles and go back into the heads-up display. Our actual bullet drop was 71.885 inches. By adjusting our axial form factor to 0.97, it's calling out for 71.87 inches, or a hundredth of an inch different. Now that we've established our true zero angle and our axial form factor, we can take our rifle system anywhere in the world, and as long as we have an accurate range to the target and an accurate environmental data, we can put our shots on target at any distance.